So I wrote about 5,000 lines of Zig last year. I really enjoyed Zig, and to see Zig is still continuing to improve, and the async stuff, apparently that's about to drop, or at least somewhat explained here, seems extremely exciting. So this is the I/O as an interface async await. To me, it's very cool stuff. So let's look at this, because I love Zig.
Okay, so what I've been working on is resurrection of async awaits.
All right.
However, it's so much more than just that.
So for those that don't know, the thing that makes Zig kind of unique is Zig is a language in which you understand every allocation and deallocation being made. So that makes it really, really difficult for something like async await, because when you just say await some function call, what you're actually doing is you have to set up something is gaining memory. Something is allocating and doing stuff and all that kind of stuff. So even in JavaScript, underneath the hood, a promise has to be created, some sort of constructors happening, all that kind of stuff. So I'm actually very excited about seeing how do they handle this, because if they're having explicit allocations as part of the language, think of Zig as like a younger C, not quite as. Some people would argue not as good as C. Other people say it's much better than C. But people who love C don't really love Zig because they love C. People who don't want to love C because of how easy it is to shoot yourself in the foot tend to like Zig much better because of how they do allocators and all this kind of stuff. So we'll get there here. And let me move myself out of the way.
I actually gave a talk on a lot of these topics a couple weeks ago in Amsterdam.
All right.
And I will post the talk here when it's available. It's not available yet. I put all my talks on my website in order. But I can also just go over some of the basics again. So here's a branch. I'll preface by saying I feel like it's solved in theory.
Oh.
I like the stuff that I did with async await before. It never felt finished. It never felt like it was good enough. I feel like there is a path towards realizing my vision with this new thing. So I'll preface it by saying that.
Hold on 1 second. Someone's saying, so follow that logic. I must be missing half this logic. Why use Zig when you could use C++? Zig is fantastic. Zig is C, but without the fun. Some people, I've met a few people that are really into C, like Casey Moratori, really into C. Also, what's it called? Also, a guy named Gurn that's been around here. Gurn did a lot of DEF CON stuff with Thor and I, and he's a super talented guy, and he loves C, and he's just like, oh, I don't like Zig. And same Muratori also seemed like he didn't like Zig, and so my interaction with people who love C and people who use C constantly tend not to love anything other than C, right? It's just like the exact same, exact same thing that people that love one language tend to love one language, and C has a lot of great things. But I don't have like a love for C. I enjoy C. I used to do a lot of stuff with C. I programmed C professionally for about a year. I enjoyed it, but my time in Zig was fantastic. It's super enjoyable. So
and
I'm very curious about this. It's always been that way. Yeah.
Kind of simple, actually.
Using Vim. Oh my gosh.
For some reason, some of the simple ideas, they're just hard to think of. Wait, this is not what I wanted.
Okay. Is bro using are we detecting telescope? NeoVim telescope? Is that what we're seeing right here?
Okay. So, you know how in Zig programs you always have to pass an allocator everywhere? Okay, well now you're going to have to also do that with I/O. I/O. What is I/O? I/O is everything pretty much. Yeah. So like async is part of I/O.
Okay.
Await is I/O. This is a little homage to the Go programming language. It's basically async without an await. It's just like crippled async await.
Okay.
We also have cancellation. I'll get into that in a minute. But then things like opening files, doing networking, mutexes, conditions.
For those that aren't super familiar with Zig, let me go over this really quickly right here. So this is obviously a pointer to a constant function, right? So that's how you do a function pointer. The first argument is an anyopeg. It's a potentially null anyopeg. An anyopeg, think of it as a void pointer, right? You don't know what the thing is. It's just a pointer to a piece of memory. Here's the starting address. We have no idea what's inside of it. So this is a potentially null pointer to anything in the memory. You have a previous state, which apparently is a mutex state, and then the mutex being passed in. So I don't know what those are. The return is specified right here. So this is a cancelable. The bang is effectively, you can think of it almost like a result from Rust. This would be the error. This would be the return type. So it returns nothing, but it could return an error of canceled, is my guess, or the cancelable. And there you go. So you get this mutex lock. So that's what's going. These are all like properties on whatever this IO object or whatever this thing is being created right here. Too much for my React brain. This is like standard types. If you use TypeScript, this is pretty much the exact same thing, except for they have this idea of, this is not a monad. So for the bros that love monads, this ain't a monad. This is not a result. You cannot do some sort of algebraic data type on top of all this stuff. It's just a very simple return type. It's like a union. It's either one or the other.
Timing. And there's going to be like much more.
Okay.
It's all related. Anything that can block the current thread of execution, including like large CPU tasks, they belong here. And so what this means is that in Zig projects, kind of one of the first things that you'll do, in like your main, is you'll either choose or you'll implement a IO implementation.
Okay.
And I have an example of this. I think I'll just find it on my gist. Oh, here it is. Okay, so I put this together already.
Recognizing GIST by UUIDs, overpowered, super cool. Okay, so it's blocking. Well, I mean, all things are blocking eventually. You just may not see the blocking. When you do an await in JavaScript, you are blocking. It just allows the JavaScript to go execute the next item inside the event loop and put yours to the end of the, at the end of the loop. Everything blocks. That's what makes Go so easy to understand, is that when you do a blocking operation, you put it behind a Go func. You go, okay, execute this, but execute this somewhere else, not right here.
So kind of in main, one of the first things you'll do, you pick your allocator. This is a familiar pattern, right? Okay, you're also going to have to pick your IO implementation. So maybe you pick an implementation that's based on a thread pool, okay, and then you grab your IO from there. Or maybe you pick your implementation from a like green threads event loop, and then you get your IO from there. Doesn't matter.
By the way, event loops are fantastic. This is also super cool, the fact that I see thread pool and event loop, and then you're sitting here saying, okay, does that mean you could write something that effectively, could you write Zig? Your underlying Zig that does a bunch of handling of events, could you at the top just write an event loop so you're just running Zig in just like a simple little event loop? Very cool. What would you compare cancel to and go? Context. You'd have to have context. This is effectively trying to make a poor man's algebraic effect system, right? No, this is not. It's a very different system, and it's an intentionally different system. Zig is not trying to make an algebraic system like Rust. It's not. It's not. It doesn't do that, and that's okay. It's just that's it.
In this example, I can uncomment this one and comment this one, and the program will have the same output. Not the same behavior, but the same output. And then you're going to get basically async await. And keep in mind that once the keyword is dropped, these can go to being a regular function name, so they won't have this weird syntax. It's just a function call, okay?
Oh, nice. Okay. Okay, so this must be if you have a function called if, you have to do this weird syntax to be like, hey, since this is a keyword, you have to wrap it in this goofiness. Okay, that's neat. Because I was wondering, I was like, dude, that's kind of crazy looking syntax.
And this is kind of like a lot of demos all squished together into one. But the point of this is that you can encode into your logic doing stuff in parallel. So here I encode the idea that I can calculate the first half and the second half, and then only later do I need the results. So I start this stuff. I do a bunch of other crap.
Okay, so they're hot. Okay. So for those that don't know, some things are cold and some things are hot. If you don't understand that terminology, what that means is promises they're called I forget it's hot something. I forgot the name of it. But when you call a promise, the constructor is executed immediately, therefore it's hot. Whereas like things like observables, they're cold until you do something with them, until you subscribe to the observable. It doesn't execute. So you could have a constructor, lazy versus immediate. They call, typically when it comes to this stuff, at least in the JavaScript world, they call them hot and cold. And so, it's like a pull model versus a push model. Yeah. Yeah, that's a lazy, eager. Yeah. So observables, if you use observables of any kind, like RX of any kind, they are cold. And so you have to first subscribe to it. You have to do something to it to kick off the operation. So this things would be considered hot or eager or whatever term you want to use
while
here.
I'm waiting. And then now I need the results. This allows you to encode that logic. And then the user of this code, which could be a different person, gets to decide how to execute your logic based on which IO implementation they pick. Exactly like how you take an allocator as a function, and the caller gets to decide how you allocate your memory. There's a ton of benefits for this. Just off the...
That's a really cool way to approach this. Okay. Dude, I just tried to scroll the code. I get this. Okay, so you get to choose how async awaits implementation is, but you still get to just use the outside right here. Okay, kind of like Rust. Rust has a little bit of that, effectively, right?
The top of my head,
you get to choose how the futures are
resource
walked.
leak checking, testing, better testing, not have to write your code twice depending on whether someone wants to use it in event loop or not. That's the big one. There's a bunch more. What am I forgetting?
Oh, I see Buffretto right there. Vim Legend, Neo-Vim Legend right there.
It's just so
Buffretto.
nice. And also by doing this in bring your own operating system, that's a good point. So you can take a package that now they used to have a dependency on the operating system, and now it only has a dependency on the IO interface. So if you make your own operating system, all you have to do is implement this interface, and now you can use all this Zig code that's now works on your hobby operating system. No one even had to care about it. They just had to use the interface.
That's cool.
Yeah, and then because it's in...
I do love if you just make your own hobby operating system. Different crowd, man. This is a different crowd. This is a different crowd than most people listening to this video, including myself. Different. It's just a very different crowd. Yeah, this is super modular. This is very well-designed code.
Userland, and it's not like keywords of the language, it actually becomes a lot easier to implement
Saturday
some
OS.
of these like niceties like cancellation and select. So for example, I implemented this queue. This is the equivalent of a Go channel.
Oh, cool.
I also was able to implement select in userland in the interface.
Okay.
So for example,
select, just for so I understand it, select in this case selects. This is effectively race. First future to go off wins, right?
And this works, by the way. This is a working example using the branch I just checked out. So
yes, it is a race. Okay, yeah.
Select is a feature where you give it multiple asyncs, and then like the first one to finish, it gets run. Now, what's interesting about this one is that it's also combined with cancellation. So you can see here we start these three things.
Is this at the end of the day? Is this an expression? I forget, because switch statements you can return stuff out of, right? You can assign a value from the execution of a switch statement in Zig. I can't remember if that's true or false. I want to say that's true. I could be wrong. Hey, I could be wrong. I think you have to break. You have to break with the value, if I remember correctly. Yeah. So that means you could actually have stuff down here, and so this all executes straight down. Okay.
And we defer a cancel. Defer cancel. So whenever we return from this function, all these resources are cleaned up and everything. So what I think is interesting about this is that Zig is not a garbage collected language. However, there's pretty minimal boilerplate here compared to like what this would look like in Go, for example.
Yeah.
I mean, arguably, it might even...
Yes, this is true. Just, I mean, he is right. This is a little bit less.
Even be longer in Go because of the lack of try.
Got him.
So to me, this is the dream, because now I can encode, I can make like a reusable package that doesn't decide which operating system it has to run on, and it doesn't decide what order things have to be run in. Like if I can do two things at once, I can encode the fact that I'm doing two things at once. And if my user just wants to like use my Zig library along with some like basic C code, they can do that. All they have to do is choose the IO implementation. That's the dead simple one that just does things like it does things eagerly at the async, and then await becomes a no op, and then it all works. So this is the future of async await. We're headed this way, and other programming languages can't do this because they don't have Zig's single compilation unit strategy. So all that work we put into incremental compilation, all that work we put into making our single compilation unit strategy work is what's enabling us to move forward in this way. And it's also going to depend on restricted function pointer types, which is quite an interesting proposal, which, long story short, just makes this code be not have some downsides that it would otherwise have.
Huh. I don't know anything about restricted function. I don't understand restricted function types. I don't know that one. I also don't understand why incremental compilation or what this does to make it so that other languages can't do. But I can say that is, I mean, remember that Zig, like you should think of Zig like you think of C, or at least put it into, like you should put it at least into the same bucket as that type of language. So to be able to see really complicated things such as async await feel really easy does feel quite magic, right?
Where am I going with async await? What am I missing, Matthew? Are you paying attention? I think I hit all the points here. Right. So then the only question there is, what about coroutines? And that just becomes a question of, is it possible to make an IO implementation with stackless coroutines? And that's, at this point, it's a separate follow-up question. So that's I'm thinking likely yes, because we'll need to be able to do that for certain targets. Like if the target doesn't have the ability to implement yield in user.
By the way, this is where I fall out of expertise on this. I don't know what I don't understand. I've never implemented coroutines, so I don't actually have like any basis to understand what this discussion is saying, because I just don't even know what those words mean. Like I understand them all individually. Like when someone says stackless, I understand that means no stack, but I can't understand it in context of this. So this is where
space, then we need the ability to do it with stackless coroutines.
Severely.
But they will become.
How does Zig handle memory as opposed to C? It's very, very similar in the sense that there's still malloc and free, but how it handles it is that everything requires you have to select an allocator, and anything that requires effectively memory on the heap, you have to have an allocator that creates it. If you've ever looked at anything to do with Jai also has a very similar-esque feature in the sense that, except for Jai, I would say Jai implements it a little bit easier in the sense that an allocator is assumed, and you can override allocators for function calls by editing this like context object, and it's pretty cool. Yeah, Jai 1075, exactly, you got it. It's actually super, super neat. But Zig does a pretty good job as well. It's just a little bit more management. I do think that Jai actually did. I'm genuinely impressed with how they handled their allocator and how to do allocation stuff. Yeah, with Zig, there's no hidden allocations. That's their whole thing. Everything you do, Zig is super verbose, but you know exactly. I wouldn't call Zig super verbose. Like I really wouldn't call it a very verbose language. It is definitely when it comes to having to specify everything, it's shocking how effectively minimal all of that. All the saying really is. It's a pretty nice,
much
it's
lower
very
level
explicit,
primitive that users usually won't touch. Like they will become they'll become an implementation detail of an IO implementation, and not something that users need to care about at all who are writing reusable packages. So only like standard library authors,
Zig is verbose for casting,
or like people who are creating like alternate IO implementations or other advanced.
For those that don't know, if this is true when you work in any language, Rust has the exact same problem. If you work in any language and you have to work with integer types, you get into this like just this the world's most annoying universe of like casting around, and Zig just happens. It feels like Zig has not great casting, and it's very frustrating sometimes with it.
Stuff we'll care about these stackless coroutine primitives. Let me try and click this link. Yeah. Okay. Why does single compilation unit enable this type of async? Particularly because what we need, it all has to do with stack usage. So the problem is that whenever you do two things in parallel, you are now heap allocating the stack of the other thing that you're doing in parallel.
Okay.
And when you have a V table, in other words, when you have a reusable interface, such as allocator or IO.
For those that don't understand V tables, like when you actually use an interface or you're using like duck typing in Go, there's actually an underlying table that when you call a function, it has to figure out where that function is and call a function pointer to execute and pass in itself, as opposed to just like, it just seems like magic to us. In Zig, if you want an interface, you literally have to hand roll your own interface.
You're going to have a function whose value is known at runtime. The problem is we need to know upper bound stack usage of that function. But if you only know which function is being called at runtime, then you're going to have you're not going to know the upper bound stack usage.
But
it's also
Zig
a problem with recursion, which we can get to in a minute. What this proposal accomplishes is it means that you'll be able to mark functions as being it means that the compiler will be able to automatically determine that a given function pointer can only be one of a limited set of things, and because of that it can say that the stack upper bound usage is the maximum of them, and that allows you to pre-allocate all the possible function call stack that you need in order to do something in parallel. And if we didn't have everything in one compilation unit, then we wouldn't know.
Oh, okay.
We wouldn't be able to do this proposal because you wouldn't be able to know what. You wouldn't have a closed set of possible functions that a function pointer could point to.
Okay, that makes sense. In the sense that if you have to put like a stack on a heap, you have to have some sort of allocation strategy that's out there, and you want these things to run. You need to know how much. It's effectively like you get to know how much the upper bound memory is. And so if you had 3 functions that take X, you'd need 3X memory to represent everything running. Okay, that makes sense. It's over allocating for sure.
Is this something I should click? Oh yeah,
or assuming it's over allocating.
I know like a set of Zig issues with just by number. I think this one's called like safe recursion. Yeah, I got it.
That's pretty bad.
Yeah, that's related for sure. Yeah, so that's where we're headed. And in the meantime, the reason that it's been taking a while for this branch to make progress and get merged is because I'm also I'm changing standard.io.reader and standard.io.writer. I'm preparing them to be assimilated into this pattern and into the async await pattern. And that's unfortunately quite an involved change. But I've switched tactics recently to try and do this more piecemeal, so I'm expecting to make progress on that soon. But I have to say, I'm sorry, but you have to prepare for some major breakage because changing standard.io.reader and writer, it really it basically just makes you like fully rewrite any code that touches it, and it's a huge pain. So I'm sorry.
That's a hard sell.
I'm strongly convicted that this is the future. It's going to be great. I'm sorry that I didn't get it first try. I think this is my like 4th iteration on async await. I really tried a lot of other things first. Yeah, I don't know. I'm not smart. I just try a lot and never like settle for something that's not perfect. That's the only like thing I bring to the table. So that's the downside is a lot of breakage. So I'm truly sorry for that. But I really believe in this being like a good strategy for the future, and I'm really excited about it.
Dang, I wonder. So, a curiosity for me is how many times can Zig go through this, like just as a language before people like become upset. Right now, Zig is still a relatively like small group of people. Right, I think I think we can all recognize that, and so due to that, you can kind of get away with this. I'm just curious, like, how long can they go before Zig 1.0 just needs to come out and there can be no more further, like, language changes? It is very hard to invent a language, and this is a big language, right? This is a very big language. Honestly, it's so new, I'd rather have them break it now. Yeah, they're breaking it now, and I think that's a good reason, right? What paradigm do you personally use when doing Zig? I did Zig for a little game server I made. Like I said, I only built one thing in Zig, which was a tower defense game that ran in ASCII. Did all the my own ANSI stuff and everything, printing out to the terminal. Tons of fun. Super loved it. I had really, really enjoyed my time in Zig, and I felt like towards the end I was really starting to move fast because I understood Zig. And I was like, okay, I get this. I get this. Is that the reason why Jai is still in private development? Well, I'm sure there's a lot of reasons why Jai's in private development. You'd have to ask Jonathan Blow of his reasons. But I have a couple of sneaking suspicions. As one, it's a bit easier to have a smaller group of people use your language because you may make some changes. But also, two, having a bunch of people use the languages, you'll get a bunch of people saying a bunch of stupid stuff, and you have a bunch of like noise to actual good issue ratio that happens. And so there's a whole bunch of fighting that has to happen, a bunch of extra effort that has to go on just to get nothing out. And so he's probably going, okay, since I want to get this language correct, I'm going to first keep it pretty small, and then from there I will go and I will go and make it public at some point in the future, right? Yeah, because the signal to the noise ratio is pretty shitty on a language, especially when it's younger, because a bunch of people use it. It doesn't meet their expectations, and then you get a bunch of the exact same question over and over again. Why don't you have monads to support it? Why are there no algebraic types? Okay, Rust has algebraic types, and so once you have that happen over and over again, at some point you just want to shut down the project and never look at it again. So it's like I can't blame the guy for just saying no, I don't want that. You know what I mean?
Yeah. All right, let's see if there's any questions here. Does this mean that async 08 won't work across dynamically linked library boundaries? Kind of. So you can annotate extern functions, and then you'll be able to have them called. But it's kind of the same problem that like outside of like if you have an event loop, you really don't want some third-party code to then do a bunch of like file system reads and writes outside your event loop. Kind of defeats the purpose, right? You need it to participate in the system.
Yes.
So it kind of creates that problem. However, because we have I/O as an interface, one thing we can do is we can implement and for some targets we actually control the libc code too. We actually can provide libc functions that then actually just call into the I/O interface. And so in some cases, we actually would be able to make this situation work optimally, because as long as we can calculate upper bounds on the stack of the functions that are being called, and as long as we can control like the I/O, then we can totally make it integrated. But there is also still the possibility that like you can just write some code that does the wrong thing, right? You could literally just write a function that says like crash the program and put that in a dynamically linked library, and then like, yeah, if you call that, you're going to crash the program.
You can like hook up an MCP server to Supabase and then execute it with elevated privileges and get all your data stolen, you know? Like you can just do things, okay? Twitter keeps telling you can do that. You can just do that, man.
Or if you just put like sleep 100, you're going to mess up the event loop, you know, in that code. So in other words, there's definitely a potential for code on the other side of a dynamically linked library boundary to not work. However, there also will be a lot of tools to make it work if you try. I hope that answers the question.
I think for those that didn't quite understand the question, if I understood it correctly, what he was saying is that if you have your little isolated island that runs async await and has its own event loop, but then a third party goes and does stuff, it's not doing stuff within your event loop. And so then it kind of makes this weirdness. And so they're saying there's ways to hopefully work around that to where you can get third party stuff to do that.
Will there be sync and async reader and writer? So yeah, I didn't explain this very well. So the way that this is going to work, the way that I tried to make this work in the past was by like making everything generic. So you'd have the same code, but then it would get instantiated in a sync way, or it would get instantiated in an async way. What I've moved towards instead is a non-generic approach. So the new writer and reader interfaces, for example. Well, let me before I switch, let's look at the current one. So let's look at writer, for example.
By the way, this code's hard to read when you're not used to this kind of code.
How does this work?
Because this is going to be some pretty deep. There's going to be a lot of really.
Okay, this is kind of like the writer. I wrapped it around this anything, but it's really not a good idea. So forget about that for a second. This is basically what everyone uses as a generic writer, and it's relying on generics, obviously. Okay, now let me switch branches.
Is Zig written in Zig?
Briefly, what
There's
I'm
a lot of
working
Zig
on.
in Zig. I think Zig is written in Zig.
Okay, so the new writer is not generic. So this is just a file. This is a struct. It's got some fields. And when you want to satisfy this interface, you have to provide you have to provide this function and optionally these functions, which have defaults. And if you do that, then you get all these methods for free. And what's nice about that is that all the code in this file is not generic, which means that the same machine code, you'll notice a lot of it is formatting code, the same machine code will be used in all of the writers, in all of the streams.
Well, I mean, this is getting deep into Zig at this point. This is super cool. I mean, I'm happy to hear that they're making progress on async await. I'm actually very curious to see where this actually goes. If it gets in, I hope people rate his Vim skills. He was doing a great. He was moving around just fine in Vim. I enjoyed all of his Vim stuff. Isn't he using? Is this Candy Code? Is that the name of the color scheme? Isn't that like one of the oldest color schemes known to man? Like right after we discovered Fire, we invented Candy Code. Syntax highlighting, if I'm not mistaken. It's a pretty old one. All right, hold on one second. Stuff's going on outside. I'll be right back. All right, this is super cool. Very happy to see that Zig's improving, that they're getting this done, because I know that async await has been something that's been on Zig's radar, at least from my reading, for like the last 2 years. So this is great. Fantastic. Well done, Andrew Kelly. Super stoked about this. I have a weird love for Zig in the sense that, you know, I did not choose Zig as my next language to learn. I have chosen Elixir, but Zig was up there. Zig was very exciting. There's lots of things I love about it, so it's great to see it's improving. I think it's I'm very excited about it. Ghosty, by the way, if those that don't use the terminal, Ghosty is all written in Zig. It's fantastic, so awesome. Zig is a great language. I'm actually very curious what Mitchell thinks about this upcoming change, because he runs Ghosty, which Ghosty is a lot of lines of code. How does he feel about this upcoming async await stuff? I'm actually very, very curious about that, because that, I assume, has a very big impact onto him. Same with Bun. Yeah, like Bun, for those that don't know, Bun's also written in Zig. So I'm very curious what the impact is going to be. I assume it's going to be big enough that there will be a lot of chaos in the coming months. All right, hey, this was awesome. Zig is a cool language. If you're going to do a low-level language, and you're looking and you're going, okay, which one should I choose? And you're looking at the options out there. I think the options out there for like a low-level language would be Odin, Jai if you're in the private beta, Zig, C. I mean, you can say C++, but who's one? C++ my right girl. And Rust. And for me, I think I'd want Zig. Or actually, technically, I'd also like to look at Odin. Odin just looks really cool. It looks really convenient. It just seems like a very convenient language. Anyways, the name is the PrimeGen. Bye-bye.